For someone, our 68 newtons
68 newtons, yes.
at 100 degrees.
100 degrees. Thank you. Course number 2, please.
Is equal to 70 newtons at 30 degrees.
Excellent.
And for number 3,
Course number 3.
is equal to 40 newtons at 320 degrees.
320 degrees. Okay. Remember, in the case of the analytical method, we need to make a chart in which we need to include all the forces and the rectangular components. What do we need to do? Remember the vector quantity, also the angle that is given, and finally the horizontal component and its vertical component. In some times we need to use this angle when it's positive, but remember, if we will have 30 degrees northeast or north of east, we need to think that we have a different positive angle. In this case, northeast means you're going to start from the north, and after that we need to go to the east. So in this case, 30 degrees is given with respect to the y-axis, so we need to change for 60 degrees. Okay? Any question until this point?
No, it's a good thing.
Thank you. Do you remember the formula to calculate the horizontal component, Andrea?
Yeah, it's the force times the cosine of the angle.
Thanks a lot. So in this case, we need to multiply 68 newtons times cosine of 100 degrees. In a similar way, to obtain the vertical component, we need to multiply 68 newtons times sine of the angle. Stop.
The physics topics that our project involve are the Pythagorean theorem. The Pythagorean theorem is a statement about triangles containing a right angle. The Pythagorean theorem states that the area of the square built upon the hypotenuse of a right triangle is equal to the sum of the areas of the squares upon the remaining sides. Vectors. A vector is a quantity that has both magnitude and direction. There are different types of vectors, like null vectors, position vectors, free vectors, unit vectors, equal vectors, and opposite vectors.
Process of building. The STEM project is composed by an aluminum table quadriculated in a Cartesian plane, lasers, magnets, and straws. First, the aluminum table was quadriculated in order to get a Cartesian plane, because it needs to have a scale. Then, the lasers were glued with the magnets to represent the vectors, the lines, and the slopes. Next, in the lasers were put straws, in which the light will pass through to make the representation more visually attractive. And finally, the magnets with the lasers were put in the aluminum table ready to use.
At this point of the STEM project, I really understand the importance of link math and physics, the same as English, because it helps us to understand better the concepts and develop the procedure in an easier way to obtain the results. I learned that it's better when you practice the knowledge and apply it in a funny way than just memorize or understand the formulas. And that is the purpose of our STEM project, that the students of junior high school actually recognize the concepts applied in our work. Thanks a lot. Chequis and chispes.
This STEM project has many benefits to the students that are going to use it. They will understand better the topics of physics and mathematics in a visual and interactive way. Also, we are making the model the most attractive possible in order to get the attention of the students. We want to wake up the curiosity of the guys, demonstrating them how the topics that they are seeing can be represented in our daily life.
With this new STEM project, I'm pretty sure we all are going to explore more about science. The topic we selected is important in physics, and it is a base to other topics, so we wanted to make sure everyone understands it in an easier way. We trust on our STEM project, and we are committed to develop it in the best way.
I think that this STEM project will be very useful for the guys in high school, because they are going to learn all about vectors in a simple and funny way that they will enjoy every time they use this device.
In this phase, we start building our model. We start to get the necessary materials and give them utility. We verify details of our project and investigate more thoroughly the topics in physics and mathematics that can be included in our project, so it will be more useful.
With the first and second stages of the STEM project, I learned a lot of things. I could apply some concepts of both math and physics in the model and its function. Also, I could understand better some physics topics when me and my classmates were building the prototype and when we were making the process of building. I hope that the other students can learn as much as I am doing right now.